Um, uh, so we will be beginning with the, or we will be continuing with the different operations on single linked list. We have seen in the previous classes how to insert a new element at the rear end of the list or at the front end of the list. Now we'll see how to delete a node from the single linked list. Okay. First thing that we will do is we will just update this first of all. Okay. Second was insert a new element at the front end. Okay. And third, now I will be adding delete an element from the rear end and delete an element from the front end. Okay. Then we will have the display. So display I will call it as fifth. Will this be okay for you? So let me just unlock the meeting. It is not giving. Okay. So now we have covered in the previous class the first two and the fifth one. We will be doing third and fourth, and one assignment will be given at the end of this class. Okay. So let's proceed. You want me to take the third one first or the fourth one first? Which one you want? Please let me know from your. It's your choice. Third one. Okay. Let's go ahead with third one. So it talks about deletion of a node from the rear end. Okay. I will try to update the main first. Okay. Case 1 was insert rear. Case 2 was insert front. And now this display will become case 5. Okay. And let me just update case 3. Case 3. And I will write printf. Sorry, it is deletion, right? So I have to delete the element. Let me write first equal to delete underscore rear underscore single linked list of first. Okay, whatever element is there at the rear end, that gets deleted. As simple as that. Okay, so let's go back and write the function for it. Let me just copy this, the function comment. I will copy this and paste it. Function name, I will give it as insert underscore array. Sorry, it is delete underscore array. Okay. Then what is the return type? Address of the first byte of the first node. Parameters, I require current first node. Parameters, I require current first node. What is the use of it? For deleting from the tail end of the list. Try doing along with me. Okay. Try doing along with me. Now, so according to the function call, I require what is called as struct node star as the return type. Delete underscore rear underscore single linked list struct node star f, or let me call it as first. Okay. Yeah, one more thing before I proceed ahead. You might have observed from the beginning till the end, I have used struct node star so many times. Can you see that? Look here, every now and then there is a use of struct node star. So how many times I have to repeat? If it is 1,000 lines of code, I have been repeating it so many times. Can I create an alias or a placeholder for such a long or lengthier thing that is available? And I can do that definitely by what is called as type defining. Okay, so let me write something like this. Type def space struct node star as capital NODE. What is the meaning of this? This struct node star has been defined as capital NODE. So whenever you want to have a struct node star written, you can write capital NODE that acts as struct node star. This is called as type defining. Data type is aliased as something else. A data type is aliased as something else, and wherever struct node star you have to write, you can very clearly specify it as capital NODE. Even you can give your name. Okay, so whatever Indira I have given struct node star as Indira. So wherever struct node star I want to use, I will cut it short to the name that is given. This is called as aliasing. Okay, let me rename that as capital NODE. Are you all okay with this? Any doubt you have? Any doubt you have? So this is only for making typing the simpler. Any doubt you have for this point?
Ma'am, is it global variable?
Definitely it has to be declared as global variable, that because this is common for all the functions. It is common for all the functions. May I know who has asked this question?
Now,
Pranav. Okay, Pranav. If I do this as part of main, I will just show you how this differs. Okay. If I do it, suppose at this point, if I do, this modification type defining is effective only in the main because you have declared it as part of the main. So only the scope remains inside the main. What about other functions? All other functions are also using. Okay, if you want to declare struct node star current, every time you are writing struct node star, instead of that, can I write capital NODE space CUR? That acts as the same, no change at all. So this has to be global in order to make sure that all the functions are utilizing the utility that is available. If you declare it, if you do it as part of main, it is available only as part of the main. The scope remains only for the main, not otherwise, not any other functions. I hope I have answered your question for now.
yes, yes, ma'am.
Okay. Now, so instead of doing it as part of main, I have done it globally as soon as I declare the structure. I have done the type defining. Now, wherever struct node star is there, everywhere you can remove that and replace that by this capital NODE. Now I will not do that. I'll keep that as it is. Whatever new functions I'm writing, only there I'll be using this. Will that be okay for you? Or any doubt at this point? Any doubt at this point? I hope no doubts. So what if I write capital NODE? What is the meaning of this? What's the meaning of this? Can you quickly comment? What's the meaning of this? Hello, class ada? Ha, class. Okay. Yeah, tell me. It is nothing but struct node star, correct. So wherever I am writing NODE, it is a pointer of type struct node. I hope this is clear. Please keep this in mind. Definitely you can use struct node star without doing this type defining. Well and good, not an issue at all. But to have that simplicity done, I have just type defined it. Okay. So let us proceed ahead. Okay. Now if I want to delete a node from the rear end of the list, what is that I need to do? Can you just do this for me or do this for yourself? What you do, you just write down in a piece of paper, draw four different nodes, having 10, 20, 30 and 40 linked together. Singly linked list. Please all of you draw it in a piece of paper. because this function you have to develop on your own. I will not be writing. Okay, I can call anybody's name. At that point in time, you need to tell me what is that I need to write there. Okay, this is more of discussion than giving the solution for it. Now, please all of you draw 4 nodes containing 10, 20, 30, 40. Connect all of them. 40 contains null at the end. I hope all of you have done this. 4 nodes you draw. Hope that it is done. Once it is done, please comment yes or done. I'll be waiting for your comments. Draw 4 nodes having the elements 10, 20, 30, 40. And 40's link part will be null. Is it done? Is it done or still doing? Drawn. Okay. Yeah. So if you have done it, now you just imagine you have to delete the last node that is available. You have to imagine you have to delete the last node that is available. So how do you go to the last node? What is the way out? Do you have any direct connectivity to the last node? Which node has the direct connectivity? Whose address I'm knowing? Comment quickly. Whose address you are knowing? It's the only first. It's only the first node's address you are knowing. So please mark to the first node one pointer named as first. I hope you are doing it parallelly. You're doing it parallelly. See guys, I can do it and show you, but when you will learn on your own. That's why I'm doing it like this. Have you done? Let me know please. 4 nodes drawn, last node containing null for the link part. Okay, and first node pointed by first. First node pointed by first. Have you done this? Okay. Next, you just imagine you have to delete the last node. And when you are deleting the last node, you are supposed to do 2 things. You are supposed to do 2 things. First thing, you are actually deleting the node. You are actually deleting the node. If you delete the last node, what is the fate of link part of the previous node? What is the fate of the link part of the previous node? Okay, let me just do it for you. Yes, it is null. You are right. You are right. Totally right. Then how do you do this? What is the way out? Okay.
Excuse me, ma'am.
Yes. May I know who is speaking?
Praveen, ma'am.
Yes, Praveen. Go ahead.
Ma'am, as we traverse to the linked list, ma'am, from the first
Hmm? Hmm?
using the variable current, ma'am,
Hmm?
we will declare one more variable and we will store the address part of each element, ma'am. And
Each
as we
element.
encounter, yes, ma'am, as we encounter that if current link part is null, ma'am,
Hmm?
so we will be having the last element's address, ma'am,
Hmm?
as we are continuously storing, ma'am.
Okay.
So uh, after that we will just discard the last element, and since we have already stored the last second last element, we will
Hmm?
make its link part null, ma'am, and other and the last element which has
It
to be
means
discarded.
it means Praveen, you need to know the address of the previous last.
Yes, ma'am.
Correct? Yeah.
Yes, ma'am.
So I have drawn it for you in what Praveen has explained is correct. Okay, what is that you need to do? You need to have the storage of previous element to the last element. Okay, now just pardon me, I have drawn it. You can understand it. You can definitely understand it by the way it looks. Okay, now 10, 20, 30 and 40 are there. Now this is having a null. Okay, this is having a null. How about before deleting this node, I should know the address of this node also, so that the link part of this node can be filled later by null. Only if you delete this, the link part of 30 would be containing an address which doesn't contain any element. So I need to update that. So in doing this delete operation, I should be doing two things. Okay, please pay attention. Once you understand these concepts, you can develop the function on your own. I hope I am very clear in the objective of discussion of this. Okay, now what this contains, you just imagine like this. 10 is storing the address of 20. Say let's suppose 10,000 is the address of node 20. Now 20 is storing the address of 30. Say let's suppose it is 50,000. 30 is storing the address of 40. Okay, let's suppose the address of 40 is 15,000. Now what has to happen? Before deleting, I should do two things. Okay, I should do two things for this operation to take place. First of all, I need to delete this node. But before deleting this node, the second thing I'm doing, before deleting this node, I should know the address of this previous node. I should know the address of previous node. So it means what? Until I reach the last node, I will be going on storing the previous node that is available to the current node. So it is as good as, guys, before I tell you how to store that, can you quickly tell me how do you store or how do you get the address of the last node? We have done it previously. Okay, we have done it in the previous class. Starting from the first node, how do you reach the last node? Can anybody comment? Even you can type in the chat. Correct. Pratiksha, you're right. Current you have to move. From where to where? From the first node till the last node. Yes? So we will be using the while loop as we have seen in the previous class. Using the while loop, I'll be moving the current to the last. So when I'm moving the current to the last, I'll make sure that there is one more variable who is storing the previous, and then I'm moving the current to the next node. So what you are supposed to do? Please have a look at it. Okay. This node initially will be pointed by first as well as current. This is okay. Is this okay or not? Please comment if it is not. First node at the beginning will be pointed by current and first as well. Okay with this? Yeah. Now what I will do, I will move the current to the next node. How do I do that? I will move the current to the next node by doing current equal to current arrow link. Okay, current equal to current arrow link. So, by doing so, current in the first iteration will be moving to the second node. Can I do it like this? Whenever I'm trying to move the current to the next node, I will make sure that currently wherever current is pointing, that is pointed by one extra variable called as previous. So how do I do that? I'll do like this. Initially, first and current are here. What I will do? I will initialize previous to current. All of you write it down. Write it down, please. Take it down as I'm telling. Okay? Let me just type it down in front of you. While, okay, while current arrow the link not equal to null. Okay, this we have done previously. What is that? Current equal to current arrow link. We have done it in order to have the incrementation done. Okay. Now what I will do, instead of doing only this much, whenever I am incrementing current, I will do this first. Just try this out. Okay. What is that I have written? I have written previous is equal to current and then increment current to next node. How this works? Let's just glance through this. At the initial stage, 10 is pointed by what? At the initial stage, 10 is pointed by what? Can anybody tell me about this? At the initial stage, what 10 will be pointed by? First and current. All of you are right. First and current. 10 is pointed by first and current. After this statement, current is equal to first. Current and first both are pointed to 10. Now what I will do? I will do this. I will declare one more variable, say by name previous, which I will assign to null initially. So when I am talking about, my current situation where I am right now at node 10, at this point, before entering this loop, where are current, first and previous, respectively. I will ask the question again. At the beginning of the while loop, where are current, first and previous, respectively? Which node is having current and first and previous at the beginning of the while loop? Ten is having, yes, first node. First and current are at the first node, that is 10, and previous is right now at null. All of you agree with this? 10 is pointed by first and current, previous is at null. It is as good as empty. Okay. Now at this point, please give me 1 minute of time. I'm sorry, give me 1 minute of time. Okay, I think now you can see at one shot. Yeah. Now at this point, the while loop begins. In the while loop, what is there? While current arrow link not equal to null. Being in 10, current arrow link is 10,000. It is not null. 10,000 not null. So enters the loop. What happens to previous? Previous was null initially. Now what has happened? Previous is equal to current. So previous is now pointing to 10. Previous is now pointing to 10. Okay. Then what is happening to current? Current is equal to current arrow link. So current is now right now pointing to 20. What about first? What about first? First is still at 10. First is still at 10. Okay. Then it goes back. Current right now is pointing to where? 20. Okay. Current arrow link is 50,000. Current arrow link is 50,000. 50,000 not equal to null. True. Enters the loop. Previous is equal to current. Previous gets overwritten with 20. So what has happened? Previous has moved from the first node to the second node. And then current is equal to current arrow link. So current where it has to come? It has to come to 30. First remains intact. I have not modified that. Are you all okay with this? Are you all okay with this? Please draw it in the paper that is available in front of you. Only then you will understand it. Okay. Next, current arrow link. Right now, it is at 30. Okay, it is at 30. 30's link is 15,000. It is not null. So enters the loop again. Previous is equal to current. Where current is at 30. So previous will point to 30 now. And current equal to current arrow link. So current will point to 40. Current will point to 40. So at this point, the current has reached the last node. Okay, it will come back. Current arrow link is not equal to null. Null not equal to null fails, comes out of the loop. So at the end of the loop, previous will be last but one node, current will be the last node. Any doubt at this point? Guys, please let me know any doubts you have at this point for this iteration that I have shown. If you want me to explain it again, I will do it again. Okay, Anushka has a question. Why first is not getting modified? First is not getting modified. Obviously, it is because first you are not moving from 10 to anywhere. Is there anywhere in the whole of this code snippet, anywhere first is equal to first arrow link is written? Anywhere, Anushka? Anywhere? No. So first has to be intact. If you move the first pointer, you will be losing forever the address of 10. Forever. Can you afford to do that? If you miss your first node, definitely all other nodes will be unreachable. All other nodes will be unreachable. This kind of fault that you are doing, if you move first to somewhere else, this kind of fault is called as segmentation fault. Many a times, whenever you are doing your linked list programs, you will encounter this segmentation fault problem. That is mainly due to the linkage error. Okay, the pointer which is supposed to link to something is pointing somewhere else. Okay, now you want me to explain it again, Anushka? If you want, I will do that. Please let me know. You want me to explain it again? Okay, yeah. So let me, um, okay, Srinivas has a question. Can we assign an array to store these addresses? See, again that is complicated, Srinivas. You're complicating the things. You have a direct way out. Okay, you can move around from one node to another node by doing just the link, arrow the link. It will do it for you. Why do you want to complicate it? Am I right? Okay. Now you want me to explain it again, I'll do that for you. You want me to take the same example or you want me to take some more another example? What do you want? This is the crucial part of this linked list. If you understand this, it's much convenient for you to develop your own function. Okay, let me start again. One different example I'll take. Fine. Then I need to, um, okay, let me add one more node for you. Okay, let me add one more node for you. I'll just cut this. Give me 1 minute of time. It's taking time because I'm doing it in front of you. That's the reason. Okay. I'll paste it for you over here. Yeah. Now what I will do, I will insert and insert. I'll come back to you, Praveen. Okay. I'll insert one more node, and let me just write say 56,000 is the address, and let me just copy this, paste it. Yes. Let me take rent 20, 30, 40, and let me write it as 50. Fine. And what should I write for this? This has to be a null. Okay with this? Okay with this? Now, let me begin with the start of this snippet code. Okay. What is that I have done here? Where is first pointing? Where is first pointing? Can you quickly comment? Where is first pointing? Yes, it is pointing to 10. I have marked it with blue arrow. Okay, guys, please note it. I have marked it with blue arrow. Now 10 is pointed by first. After this statement, current is equal to first. After this statement, where what will be pointing to 10? After the first statement. After the first statement. Anushka, I want your participation. Okay. What will be pointing to 10 after the first statement? After line 1. It is current and first. You are right. Okay. It is current as well as first. Nandesh, please check it out. After the first line of code, I will have current as well as first pointing to 10. All of you agree with this? Then what about the second statement? It is independent totally. Previous is equal to null. Previous is somewhere, aram se it is relaxing. It is thinking that I don't have any other work right now. That's why it is assigned with null. Okay? It's just relaxing. This is merely a declaration. Okay? Then I'll go to the third line of code. At this point, all of you know that 10 is pointed by current as well as first. Okay? So it's a while loop. While current arrow link not equal to null. It is current's link. What is there in current's link? Address of second node, that is 10,000. Okay? 10,000 not equal to null. Is it true or false? Is it true or false? Quickly. It's false. Definitely. Okay? Now what happens? It enters the loop. It enters the loop. At this point, current arrow link not equal to null. 10,000 not equal to null. Is it true or false? You are telling it as false. It has to be true. 10,000 not equal to null. Okay? It's true. Shreyas, it is true. Now, when it is true, it enters the loop. Inside the loop, what is there? Previous is equal to current. Where was previous? Previously, it was somewhere else. It is nowhere in the picture. But now, directly, it has entered into a position. What is that position? Previous is equal to current. What is on the right hand side? Right hand side is the one which contains the address of the first node right now at this point. Okay, that gets assigned with previous. What current is having? Current is having the address of the first node. That gets assigned with previous. So previous now will contain the address of 10. It means what? After this line of code, after this line of code, 10 contains how many pointers? 10 is pointed by how many pointers? Fatafat. Yes, it is 3. Why 3? Because I am talking about previous, I am talking about current, I am talking about first. All 3 are pointing to the first node. Agreeable. This is okay with you. Have it in front of you now. You just have the imagination done in your mind. Okay. Now, in the line B, what is happening? Current is equal to current arrow link. From 10, current's link. What is current's link? 20. Address of 20. So, current gets moved to the second node. Now the current is pointing where? It is pointing to 20. What about previous? What about previous? Still it is pointing to 10. What about first? First is immobile. Immobile. It will never move. Okay. So quickly can you tell me what all are the positions of previous, current and first in terms of element? Which element is pointed by current? Which element is pointed by previous? Which element is pointed by first? Fatafat. Okay, previous is to 10, current is to 20, first is to 10. All of you are right. Now, with this background, it goes back. Goes back because it is a while loop. Okay. Current arrow link. Now current is pointing where? 20. All of you have said it. Okay. 20 is a link. What is 20's link? 50,000. 50,000 is not a null. So it enters the loop. All of you are okay with this. Now what is happening? Previous is equal to current. What current contains now? Can you tell me what current contains now? Current contains 20's address. That gets copied to previous. So previous now is pointing to 20. Can you quickly tell me where are first, current and previous at this point? After line A in the second iteration. Where are previous, current and first? I'll be waiting for your comments. Okay, previous and current are at 20, first is at 10. Previous and current are at 20, first is at 10. Correct. First, now onwards, first I will not bother about because first is not changing. Okay, only bother about previous and current. So at this point, after the line A, previous and current both are pointing at 20. What happens to the next line? Current equal to current arrow link. Where current is moving? Current is moving to current's link. Okay, what is that? 50,000 is the address of the next node. So current moves to the 50,000. Okay, so current right now will be pointing to 30. Previous is pointing to 20. Goes back. Goes back. Okay, current arrow link. 30's link is 15,000, not equal to null, obviously. So enters the loop. Previous is equal to current. Now where previous will come? Right now wherever current is pointing, to that point previous moves. So previous moves to 30. And current is equal to current arrow link. So current moves to 40. Are you all getting this? Or still you have doubts? So this continues until it reaches 50. Until current reaches 50, previous reaches 40. So previous is a follower of current. It is a follower of current. Always previous will be one step behind the current. So what previous will contain? It is always with the kind of code that is written, it is always one node before the current. Always. It is a follower of current. So at the end of these 5 lines of code, at the end of this loop, current will be where and previous will be where. Fatafat, I need answers very quickly. Where will be previous, where will be current at the end of the loop? Previous will be at 40, current will be at 50. Anushka, may I have your answer? Where are you, Anushka? I have repeated this for you. You're there?
Yes, ma'am. Yes,
Yes,
ma'am.
tell me. You have understood now.
Yeah, ma'am.
Okay, yeah. So
Thank you, ma'am.
at the end of this loop, 40 will be pointed by previous, 50 will be pointed by current. Now what is my task? Can anybody tell me what is that I need to do to delete at the rear end? Jaldi bolo. We have discussed dynamic memory locations and deallocations. Okay. Which are, which is the node, which is the, okay, Praveen has answered to this question. Which is the function that is useful to delete a node or free the memory? Which is the function that is used? Free is the function. He has given the answer already. Okay. Free is the function which is helpful for me to free the memory location that is already allocated. So I will do these two steps. How? All of you are right. You are 100% right. Good work. Okay. Good going. I am very happy for your answering. Yes. Next, what I will do is I will do this. Free of current. Okay. Free of current. Then I will write. What should I write next? Can anybody guess? Wild guess. You are right, Ananya. I will be writing. I'm so happy for you guys today. Yeah. Previous arrow link is equal to null. So nice of you. Have I done with the things? Or is there anything else left out? Return previous. Do I need to return previous? Current equal to previous. Why should I do, Praveen? Next time if I call delete function again, current and previous are beginning from the beginning. Don't get confused. Don't get confused. If you want to delete at the same time, if you want to delete more number of elements, okay, with a single call, only then you require that. Otherwise, you just utilize it and throw it off. Okay. So before this, I would definitely want to do this. Okay. What is that? I'll write printf the deleted element equal to comma. Yeah, what should I write? Any guesses from your end? Do I need to write current? Or if I write previous arrow info, what will happen? What is the element to be deleted? Yes, Afzal, you are right. It is current arrow info. Current arrow info. So I will just print what is the data that is getting deleted and then I will print the current. Okay. Then previous arrow link is equal to none. Is this okay? Any doubt you have at this point? Probably I'm left out with only 5 minutes in this meeting. Okay. But you have to join back, that you know already. So let me just paste this over here. Guys, whatever you have told, I have done the same thing. Okay. Next, what I will do, I will return the first. Okay, actually this is not required. Actually this is not required. Let me just do it as void. Void. Or will this be okay if I write like this? Can anybody comment on this? Have I missed anything in this? Any guesses from your end? Is there anything that is left out in this function? Any guesses? Okay, join back with the answer. Yes, you will be getting around 2-3 minutes of time. Join back with the answer. Anything left out in the function or the function is totally correct. It's proper. It's proper. What if there is exactly one node? What if the linked list is empty? Those conditions are yet to be addressed. Okay, join back after 5 minutes. Thank you all.